In this lesson, we will be discussing the physics of Earth's climate. Let's start big. Remember that Earth is the third planet from the Sun. When Earth formed, it had surface water in the form of oceans, volcanoes, and a carbon dioxide-rich atmosphere. These are all important in what we will be discussing today. Let's examine this picture, starting with the volcanic eruption and the eruption cloud, which fills the atmosphere with important gases like CO2. The CO2 will then be absorbed into the ocean. Finally, due to plate tectonics, the ocean crust is subducted under the continental crust, and these gases that were absorbed into the ocean go back into the lava for another volcano. That is the cycle that replenishes our atmosphere with carbon dioxide. So then how do we get oxygen? The answer to that question is photosynthetic life, which uses the process of photosynthesis to turn carbon dioxide into oxygen. It is important to remember that if there were no volcanoes, the atmosphere would run out of CO2, and then we would run out of oxygen. Let's do a quick recap. Volcanoes spew ash, which replenishes our atmosphere with CO2. This CO2 is then absorbed by the oceans and goes back to the volcanoes, or is turned into oxygen through photosynthesis and we breathe it in. Now let's look at how this all relates to climate. The Earth has a natural greenhouse effect. This is a process where visible light from the sun passes through the CO2 in the atmosphere. It heats up the surface of the Earth. The Earth then emits infrared radiation, which allows it to cool off some. If there is too much CO2, then the infrared radiation is trapped. Humans have been a large cause of excess CO2 in the atmosphere. This prevents the Earth from cooling off. We can see in this graph that as carbon dioxide levels increase, the temperature of the Earth does as well. This unnatural global warming has devastating effects on the Earth. It has caused the loss of habitats and species. We can help fix this by using alternative energy sources and watching CO2 emissions. Now that we have discussed the climate of the Earth, we should look at how we compare to other planets. Unlike the Earth, Mars has completely cooled off since its formation. It has no more volcanoes, so it has virtually no atmosphere. It is considered a dead planet, like the Moon and Mercury. Venus has not cooled off yet, but since it is closer to the Sun, it had less surface water at its formation. This meant that there were no oceans to absorb the CO2 in the atmosphere. As the volcanoes continue to add more CO2 to the atmosphere, less infrared light escapes. The planet continues to get hotter and hotter. This is called the runaway greenhouse effect, and it has caused the surface temperature of Venus to reach 462 degrees Celsius or 864 degrees Fahrenheit. Today we've learned that the Earth is not too cold and not too hot. It's just right. As people, we have to be aware of our actions and how they affect our beautiful planet.